Alright, so moving on to questions for hypothesis tests for proportions. Type of question you'd see on our third exam related to hypothesis testing. Okay, I actually will have a format for the exam that's very similar to this. Okay, so when you're doing a hypothesis test, you'll see all these different pieces, and it'll be very similar to the way I have it here. Alright, so prior research shows that 39% of college students do not study for their exams. The professor thought 39% was too high and hypothesized that less than 39% do not study. Okay, so the professor believed that most of the students study, and 39% seems like a lot. Okay, the professor randomly sampled 80 students and found 21 claimed that they didn't study for their exam. Okay, does this indicate that less than 39% of college students study for their exam? Use the 0.05 significance level for your test. Okay, so state the null and alternative. Now, it's always going to start like that. Now, the null will have the equal sign, and the alternative will be directional. Okay, so it'll be less than, greater than, or not equal to. Okay, so equal to what? What are we hypothesizing right now? So they hypothesized that the professor hypothesized that less than 39% study for their exam, did not study for their exam. Okay. So P equals 0.39. Those two numbers should match. All right, what side test is this? We're testing if P is low or to the left, right? Low values would be to the left. High values are to the right. So this is a left tail test. Okay. Calculate the appropriate test statistic. Now, so I'll have our formula sheet printed out. The exam, you'll be provided with the formula sheet. Okay. So what are we doing right now? We're doing Chapter 8, test statistics. This is a test statistic for proportion, right? So let me go and write that formula down. Alright, so P, that's from your null hypothesis. Notice you don't write sample statistics here. You write population proportions here. So it's not P hat equals 0.39. We know what P hat was. It's coming from our sample. It's 21 out of the 80. Right? We're hypothesized about the population proportion. So P comes from the null hypothesis. What's P hat though? P hat, I just said, we get that from our sample, 21 out of the 80. In the denominator, be careful here. This is P, not P hat. N, our sample size. How many people did we sample? We sampled 80 people. Okay. Let's go ahead and calculate this. So 21 divided by 80 minus 0.39. Okay. The denominator there, 0.39 times 1 minus, let me use parentheses, 1 minus 0.39. Okay, divide that by 80, close the parentheses for the square root sign. Try not to round your denominator too much, otherwise it will screw up, because remember in the end we need z to be correct to 2 decimal places. So try to not round these very much. I can actually use exact values in my calculator by pressing on that one, then saying divided by, and then press on that one. Press enter. Okay, so I get negative 2.34. That second 3 gets rounded up by because of that 8. Alright. Determine the p-value. Negative 2.34 is back here. Now p-value is always the probability of being that extreme or more extreme. It depends on the side of your test. What extreme means. So in this case, we have a left tail test. So extreme is going to be the area to the left. Okay, so that's going to be the p-value. P-value equals that area. So let me pull out my table. Negative 2.34 0.0096. Okay. Alright, you should know how to calculate p-values for right-sided test, for two-sided test, and for left-sided test, which is what this one is. Okay, on your exam, it probably won't be a left-sided test, right? So you need to know how to do it for all these different types, which I think you practiced in your homework and on the handouts. There's more practice like that. Okay. Also, you should know how to calculate critical values to make decisions using critical values. The problem on the exam might not be a p-value, it might ask for critical values. You should know how to do them both. All right. In this example, the critical value, since this is a alpha, if we had to do critical values, we would put all of our significance level on the lower tails, left tail test. We'd figure out what this value is, that cutoff. 1.645. Right? I think that's negative, or let's see, negative 1.645. Let's double check that. Yeah, right there. Between these two, negative 1.6, 4, and 5, because it's directly between those two. Okay? So that's your critical value. That's your p-value. Alright, make a decision. So based off these, you should be able to make a decision, one or the other. Right? Am I going to reject or fail to reject the null? So using the p-value, remember, we will reject if this is less than 0.05, which you're getting from our significance level, and it is. So we are going to reject the null hypothesis. Okay? Also, using critical values, we can see, so this area over here would be our rejection region, and negative 2.34 is in the rejection region. It is less than negative 1.645. Okay. So we reject at the 0.05 level of significance. Okay? You get that from the problem statement. Alright. There is or there is not enough evidence to suggest that college students study before their exam. So we reject this, which means that there is evidence for that. So there is sufficient evidence to suggest that the percentage of college students that study before their exam is less than 39%.